All right. Failure and mistakes give you experience. Thanks for sharing that, Aaron. And I'm here experienced today because trust me, I've made countless mistakes, countless errors. And they said a smart man learns from their mistake, but a wise person learns from the mistakes of others. So hopefully you can learn from my mistakes and you don't have to make them yourselves. That said, let's go into our curriculum today. Do we have any questions from yesterday's curriculum? So yesterday we talked about conditional execution. We talked about using an if statement, an elif statement, an if, an elif, and an else statement. We also looked at nested loops, right? And we went ahead and looked at different ways that we can address errors for user inputs. Okay, so in a nutshell, that's about it, what we did yesterday. Today, though, we're going to look at loops and iterations. Our code has been running only one time all along. So we want to set it up so that it's repetitive, so we can repeat it. Okay, so that's what our focus would be on today. So a few things that we'll need to do. We'll go back and talk about variables a little bit. We'll look at iterations that are indefinite, and then we'll look at iterations that are definite. And we'll see how we can exit out of an iteration if we meet a certain condition. All in all, we'll learn how to run the same task multiple times, and we'll also learn two different types of loops and when we can apply them. My goal will be to get this done in less than an hour so that we can do a lot of practice, because there's a lot of practice you can do. And what we need to be doing is having fun. Try out many scenarios. And like I said, there's coding is a creative art. So there might be 10 different ways of writing the same piece of code. You just have to build your own signature, stay consistent, and then make sure that you avoid errors. All right, so let's get started. Variables. What are variables? Remember we said variables are just a place in memory, right? Like a bucket where you put stuff inside. So normally you want to be able to create that space in memory. Think about giving birth to a child. You want to first give birth to the child before you give the child a name. Okay, I know nowadays things are different. People do their baby showers and choose their names of the babies before they're born. But without the baby being there, you can't really assign a name to it. So declaring a variable is what's known as creating that, or creating one. So a common error that we might have, as you can see here at the bottom, we might say we want x plus 1 to be assigned to x. This will give us an error. It's a common error because we are trying to update the value of x when x does not really exist at that point. So it gives you a name error when x is not defined. The way you can avoid this error is to make sure that you initialize, you assign a value for x. Just a simple assignment needs to be done before you can update that value. So this is what needs to be done here on the right. You say x should be equal to 0, and then you can keep updating it as you need. So when we're looking at a loop, you want to make sure that you assign a value to your variable before you get it into the loop, because the loop is going to be updating it. Does that make sense, everyone? Good. So let's jump straight into while loops. While loops, again, they are indefinite. What do I mean by indefinite? There are some cases when you don't know how many times your code is going to run. That means it's indefinite. You don't know the number of runs it will take. For instance, somebody puts you at the door of a bar or a nightclub and they say, okay, you're here to collect tickets. So all you're doing is just punching in the number of people that are going in. You don't know if there's going to be 2 people coming in, if there's going to be 100 people coming into that party. You're just there to keep track of the number. Once you get to a certain number, you can then say, stop, we are at capacity, okay? But you're not quite sure. So a few things here. You write your while statement. You start with the while word. You give it a condition. We talked about conditions yesterday. So a condition is an expression that is either going to return true or false. If this condition is true, then whatever is within this body, the indentation, the body of your loop gets executed. Just like the compound statement we talked about yesterday for the if else, if else, okay? A compound statement ends with a column. So after that column, this block of code gets executed if this condition is true. If the condition is not true, the whole block of code is skipped and you go to the next line of code. Does that make sense? So again, evaluate the condition, which will result to true or false. If the condition is false, you skip and you continue execution at your next line. If the condition is true, execute the body and then go back again to the condition. So one thing that happens is within the body, you usually update the condition or the counter. If you're saying while x is greater than 0, do all these statements. Somewhere along the line, you're going to say update x by adding 1 or by subtracting 1. Okay. And then eventually you want to get to a point where that while condition is no longer true. And then you skip out of your loop and execute the next statements that follow. The else block is optional. You don't really need to have it in there. Most people have it in there for readability or just to reinforce what they're typing. But often you will not see that. You just have these statements, just start right here in the indentation, without the indentation, and continue. So it's very useful if you're going to look at a text file, you want to see the contents of the text file, you can use the while loop to check if there's another line in the text file. Okay, you can also use it to check if a user has finished entering values. So when we're asking for the user to input a name, input stuff, you can say, okay, input a value or input a particular string to show that you're done, or input a particular number to show that you're done. So all you want to do then is you say while that value that they entered is not what is the terminating value, then keep doing this, and it's going to go on and on and on without ever ending. Does that make sense to everyone? All right, but a few tips to mention. Again, the else block is optional. In some cases, if you have this while condition and it's always true, this means your code is going to run forever and ever and ever, well, without end. Okay, so you want to make sure that when you write code, you make sure that your condition is something that is correct. If your condition is incorrect, it's going to run until your battery of your computer runs down or your CPU gets too crazy. I mean, you definitely want to make sure that you avoid a scenario like that. Does that sound good to everyone? So let's take out a quick example here. Let me escape from that. And let's go into our Jupyter notebook. So day 4, let's add a new, oops, sorry, that's not what I wanted. I need to add a new Anaconda notebook. I'm going to rename that and call it day 4. So in this case, we want to try while loop. Maybe I should not use the word try. Let's say, let's execute a while loop. Okay. So how do we do that? That's just a comment. First, we want to give our variable a name. I'm going to call it counter. That's the name of the variable. We need to initialize it. We need to give it a starting number. Let's say 10. The variable is 10. Now I can write my while, and you put in a condition. Okay. The condition in this case has to be an expression which is either going to be true or false. So now I'm going to say while the counter, if I can spell correctly, is greater than 0. So it's going to test this condition. If this counter right now it's 10, it's greater than 0, then I can go ahead and print it. After printing it, I need to update that counter. So to update the counter, I'm going to type it very mundanely. Counter should now be equal to counter minus 1. Does that make sense? So I'm going to start from 10. I'm going to check if 10 is greater than 0. Yes, that's true. It's going to print out 10. And then the counter is now going to be 9. And then it goes back outside and runs the code again. It's going to keep running it until the counter is no longer going to be greater than 0. So I can go ahead and get out of that loop and decide to say, want to print a statement that says done. Okay, so that would be a simple example of making a countdown program. Now I don't really need an input. If I execute this, you can see that it counts from 10 all the way down to 1. When it gets to 0, when counter is equal to 1, 1 is greater than 0. So it prints 1, and then your counter now becomes 0. When it goes back out, 0 is not greater than 0. So it gets out and it's done. What questions do you have? Everybody good with this so far?
Yeah.
Excellent. So if you want to make it more dynamic, you can ask the user to enter a number, right? And let's say counter input. And we get the input function and say enter a number for your countdown. Say enter a number for your countdown. Now we want the counter to be, let's make it an integer. That way we don't get trouble. So integer would be counter underscore input. Oh, I did not spell it correctly. That's why. Good thing I checked. Okay. So without doing my user validation, the try catch, I'm assuming that the user is going to be really nice. If I press play, now it wants me to enter a number 4. I cannot spell. For the countdown, and the number I enter is 50. I press enter, it's going to count down from 50 all the way to 1, and it's done. Now let's make it something that's reasonable. Maybe 5. We enter that and we put 5. Execute it. Oops, sorry. I should press enter. And it counts it down. So that's how a while loop is going to execute. Now let's go back to our code and take a look at it. So does that make sense what we've done, writing a while loop? Questions, comments, concerns?
It's good.
Okay, good, good. You can also set it up to be infinite. If we want it to be infinite, the way we'll go about doing that, let me escape from this again. The way we'll go about doing that is to make sure that this condition is true. If we want this code, it's going to crash our system because it's always going to be true. This is going to keep looping and looping and looping and never end. Except we'll talk about this later on today. There's a way that we can get out of it. So let's not do that. Let's make sure that at some point in time, this condition is going to be false, and then we can get out of that loop. One thing to point out again is the loop is the outer repetition. The iteration is the inner repetition. Okay. So each time you go through an iteration within your loop. Okay. So you have an iteration. The first iteration is when it's 10, assuming that we're still having 10 here. The second iteration is when you have 9. The third iteration is when you have 8, and so on and so forth. Okay. So that's what we get when we look at a while loop. Again, in this case, we were not really sure how many times a loop is going to run. You see a lot more of those as well. Actually, let me do another example real quick. So it's a enter a number. Let's just keep that. So enter a number or on to exit. Okay. So here we're saying if the person enters done, we're going to exit. So let me comment this out. I don't really need to update the counter anymore. Here we're going to say while the counter is not equal to done. To use double quotes actually. Here I don't need to, I don't think I need this anymore. Let me comment that out. I don't want to convert it to a number. That's fine. If the counter is not done, then exit out of it. So let's go ahead and print that out. So if we execute that, it says enter a number or done to exit. So let's enter 2. Prints out 2. Let's see. What did I miss? So here, this is one of those that's going to keep running endlessly. Okay, so it's always going to be, as you can see, it's crashing my system. It's always going to be true because counter has to be an integer. The integer is never going to be that. So let me go ahead and stop that execution. Yep, stopped, hopefully. And I should use counter input instead. Come on. Okay, so it's really going crazy on me. Let's see, cannot stop it. Excellent. All right, when it finally stops, we'll come back to it. Let me go back to that example and let me move on from that example so we can carry on with our for loop. Okay, so after the case of a while loop, which is indefinite, we look at a for loop. With a for loop, you actually know the number of times that you're going to run your piece of code. Okay, so the for loop, very similar to your while loop. It comprises of the for keyword. You know, you have a space and then you give a variable name. This is very important. Here you're saying for I in this range, it does not necessarily have to be I. You can give it any name. You can say for number in this range, for numeral in this range, for my information in this range. You give your variable any name that you want. Okay, it's going to represent each value within your range or each value within your sequence. So for loop is usually very useful when you have a list of things or when you have a bunch of results that you're looking at, okay? So now the in keyword is also important, and an iterable. An iterable is what you have at the end of the header in your compound for statement. What is an iterable? An iterable is any object that you can iterate over, that you can count over. So it's anything that belongs to a collection per se. So we haven't talked about collections now. We'll talk about them next week in our next class, but that would definitely make more sense. But in a collection, you have a fixed size. You have a particular number. You know the number of elements in your collection. So if you have a World Cup that was played in Qatar, you know there are 24 teams. So you have an idea, you know that for every team, I'm going to maybe print the name of the team, or print the captain of the team, or print the team's goalkeeper or the team's coach. So in that case, you know that this is the number of times that this particular iteration is going to run, or this particular loop is going to run. That's why a for loop is definite. Okay, if you're looking at a class, you know the class is 80 students. You want to print out the names of each student in the class, then you can say for student in class, where that class is a collection, a list, a set, a dictionary, whatever collection that we'll talk about shortly, and then we'll go from there. Okay, so obviously it's a compound statement, so it ends with a colon. And then just like the while loop, just like the if statement that we talked about yesterday, you get to execute all the codes within the indentation in the body of the loop. If, well, in this case, it's not a condition. You get each single one of your elements in the collection and execute that code for each item in the iterable. Okay, so it's also straightforward like that. We'll look at a few examples shortly. But yeah, nested loops, you can also have loops within loops. You can decide and say, okay, for all the states in the US, you want to do a particular execution. Now for each state, you want to also loop over each state and print maybe the capital of the state. And for each capital, maybe you want to print the, I don't know, the head of the capital, the mayor, or something like that. So, or the number of schools that they have in that capital, and so on and so forth. So just like you can nest if statements, you can also nest loops, whether it's a while loop or a for loop, and so on. But always remember that loops are very useful in collections. We'll talk more about that next time we look at it, but it's very, very, very useful for us to be able to do all our computations. Sounds good? Next up, next thing we need to talk about, yeah, maybe I should actually, before I do that, maybe I should actually show an example of the for loop, just like I did with the while loop. Hopefully, see, this guy is very angry with me. As you can see on here, I probably broke it, definitely, because I had a very horrible query that was running. So my query was infinite. Sorry, not a query. I don't know why I keep saying query. My code was infinite, so it crashed my my example, and I should not be using that. So let's go about undoing everything that I did earlier. So this should be less than 0. Our counter is less than 0. Oh, sorry, counter greater than 0. Okay. So yeah, this worked just fine for us before. Let's try it and say 10. And it did just that. So let's execute a while loop. Sorry, a for loop this time around. So what would be a good example for a for loop? For a for loop, let's go ahead and start by creating a list. I know this is not going to make sense to you now, but a list in Python is usually enclosed in square brackets, okay? In square brackets, and then you can have list of items. In this case, I'm going to have list of foods, okay? So hopefully everybody is okay with Eru. And then we can also make sure we have Achu. And then we can also make sure we have rice. Let's make it fried rice. And let's try fufu corn. No, fufu corn is too much. How about koki? Awesome. So now we have 4 different food stuff. Is there any other food that I'm missing? Anyone needs us to add it on there?
Water fufu.
There's already Eru. You want to add water fufu in there? Okay. Let's make sure we have Eru and water fufu, achu and yellow soup. I'm making sure for the children, obviously I can't spell fried. Fried rice and chicken. Koki and plantains. And let's call kati kati. Awesome. So now we have a bunch of different food stuff. Let's make this smaller. There you go. Now we can see everything. Now, if we want to do a for loop, we start with a for keyword, and then we give a name of a variable that's going to hold each one of these food stuff in here. So let's just say chop. For each chop, right, in foods. So it's going to go into that foods list and pick each one of them and do something to it. What we want to do here is just basic. We want to just print it. So what we should print is the chop. And that's it. Or we can say, I like whatever the food is. So if I execute this, I like egg one water fufu, I like achu and yellow soup, I like fried rice and chicken, I like koki and plantains, I like kati kati. So that's how you keep executing it. Now we know the number of items in this list, so it tells us that's the number of times that this particular line of code is going to execute. Sounds good to everyone? Awesome, awesome, awesome. So that's as simple as that when you look at while loops and for loops. For the while loop, we don't really know how many times it's going to run because we don't know if this guy is going to enter 1, 10, 20, whatever they enter. That's going to determine how many times it runs. Okay, so for loop is definite because we know how many times it's going to run, but while loop is indefinite. You want to make sure you avoid having an infinite loop. Okay, so avoid infinite loops.
So chop becomes a variable that we are assigning to the items in food.
Exactly, excellent. So that's what chop is right now. Chop is each one of these. The first time we execute our code, chop is going to be ego and watafufu. We go in and we print that. The next time you go to the next iteration, chop is now achu and yellow soup. You go ahead, you print it. And then you go on to the next item on the list. You keep doing that over and over until you get to the end of the list. And then you get out of it. You can go ahead and say, maybe when you're out of it, you can print another statement and say, I'm no longer hungry. And that should be it. So if I execute this again, it should go ahead and tell you all of those things. And I am no longer hungry because you're done printing everything. Does that help?
And you've eaten all that, so
I'm telling you. I
If
don't
you're
know
still hungry, that is a problem.
if you're still alive. I don't know how the toilet is going to receive you. All right, Miss Angie, you have a question.
No, you just answered the question. The one
Okay.
you, yeah, for the chop and the food. So I was trying to confuse the statement, but you just answered it.
Yeah, that gets really tricky. That gets really tricky for some people because most of the time you say somebody will have 4i in foods, that's going to work just fine. Just know that instead of chop in here now, you have to have I. But instead of using I is usually an iteration, right? It's not useful to use those words that are not mnemonic because the more you look at it, it will not help you. Sometimes people usually would use food for food in foods, where one is a singular, another is a plural. You just want to make sure that you read it clearly. Okay. Or you can say, okay, for a plate in foods, then you know, okay, for each plate, I like that plate, I like the other plate, and so on and so forth. Just use words that will help you so that when you read it, it sounds just like English. Okay. Same with the while loop. Okay. In the while loop, you're going to say, while your counter is greater than 0, print the counter, update the counter, and then go back again and do the same thing until you're done. You print done. Sounds good? Question, Mr. Aaron.
Yeah, I see. I see you commented that while loops are kind of infinite and you have to avoid them. But I think there are situations where you cannot deal with that. So I was playing with a few code here. What I was trying to do was to have a user, um, enter 3 different numbers, and after the 3 trials, if they are not able to enter an even number, then it breaks and tell them, hey, you've done your 3 trials and then you failed the test, right? And
Exactly.
I wasn't sure if in that situation you can use a for loop because um, yeah, I wasn't able to use a for loop in that situation.
Very, very good. Very good. So that's a good example. So our goal here is to get the user to enter 3 numbers, right?
Yes, to enter number to do 3 times to
Okay,
enter.
to enter 3 guesses. Let me put it that way.
Exactly. Yes,
So, and they should be numbers, right?
they should be numbers.
Awesome. So what you need to do then now is you know that number of guesses
Mhm.
is 3. So you need to set it up ahead of time. Once you've set up your
Mhm.
number of guesses as 3, you
Mhm.
go ahead and use your for loop because you know it has to run just 3 times. Okay. So
Mhm.
you say for number of guesses. Sorry. Yeah, I don't know if, well, let me explain this one to you anyway. It's something that I didn't want to go through it, but it's what you use is a range. There's a function in Python that is known as a range. So let's say for number in range usually takes a number in it. So if I say range 5, it means it's going to run 5 times.
Mhm.
But now I know that I want it to run the number of guesses. So I'm going to use for range number of guesses. Does that make sense?
Mhm. Mhm.
So it's going to run 3 times. So let's make it simple here and just print, say print number of guesses left, right? And then we'll
Mhm.
have number of guesses. Come on, there you go. So that's what it's going to print. But before we print it, the first time it's going to print 3, right?
Mhm. Mhm.
When it prints 3, we now say input. Let's say the guess maybe will now be equal to an integer. Input, enter your guess,
Mhm.
right?
Mhm.
So with that, you should be able to get them to enter a guess. You convert it to an input, and it's going to be your guess. Once you've done that, you need to update your number of guesses.
Yeah. So in this case, it's gonna be number of guesses plus 1.
So minus equal to 1.
Yeah, minus 1. Yeah, 10.
So this is one of those, let me make this bigger. This is one of those ways that you can update it, but let's not do that. Let's make sure it's clean for each one of us to understand. The number of guesses minus 1. Your number of guesses left now will be 2.
Yeah. Yeah.
Okay. So let's go ahead and maybe print again after you've guessed. Let's go ahead and print. Let's say you guessed. Does that make sense?
Yeah.
So it's going to keep running, and then also you want to maybe at the end of the day tell them that, hey, all done. So here you define the number of guesses you want to be 3.
Yeah.
They're going to guess 3 times. Now, if you want to check if it's even or odd, somewhere in here, you're going to need to say, okay, if the number is divisible by 2, then tell them, yeah, you won. Your guess is good. If not, so again, piece by piece, you eventually get to your solution. But let's try running this one out and see. So number of guesses left, it tells us is 3. Let's enter our guess, 15. Now it's asking again, you guess 15. Number of guesses left now is 2. Enter your guess, 5. You guessed 5. Number of guesses left, 2. Enter your guess, 33. Guess 33, and it's all done.
Yeah, it's. I think this is good because I started with counter equal. So number of, again,
Yes.
I started with the counter at 0, and then I increased the counter while using the while loop. So by the time I go to 3, and if all the entries were not divisible by 2, right? Then you get, okay, it's cool.
Good. So you can, if you want to specify that, hey, they have only 3 guesses, then it's good to use a for loop and then use that range. We're going to talk about the range at the end of the day to do that. Otherwise, if you want them to keep guessing until the end of time, then you can change that to say, while your guess is not an even number, keep guessing. And then maybe you want to count how many tries it took you to guess the right number, and so on and so forth. So there are fun games that you can make with Python. Again, you can decide and say, okay, this is a guessing game. You decide randomly what number you want them to guess, and then they'll guess that number. If it's too high, you say, sorry, your number is too high. They'll guess another number. If it's too low, says it's too low. You keep going until you get the actual number, and it tells you, you guess the number in 10 tries, in 5 tries, in 20 tries, and so on. Does that help?
Cool. Yeah.
Excellent. Very good question. I really like that. All right. So let's go back again. We've looked at while loops, and we've also looked at for loops. I believe there's one more thing to look at. Exiting loops. At some point in time, maybe you don't want the entire loop to run till the end, right? You can use the break keyword to exit the loop totally, to terminate the loop and then go about your business. Or you can use the continue keyword to skip that particular iteration. If you use it, it skips that particular iteration, but that's only if a particular condition is met before you can do any of those. Does that make sense to everyone?
Yeah.
So let's try this out with our countdown.
So you cannot use break and continue if you're not using a loop. Is that right?
Yes. You can only use break and continue within a loop. If you try to use it outside a loop, it will give you an error message.
Yeah, okay. Because that's what I was saying. I couldn't use it, but I wasn't sure if I was doing something wrong.
Oh, good. Yeah, so let's go about this counter that we did earlier. We went ahead and said, while the counter is greater than 0, just keep counting down from 10 to whatever. So we can decide and say, where's my enter? If counter is equal to 5, make sure that you're using 2 equal signs, because if you use 1, it's an assignment operator. So if we use a condition here, if it's equal to 5, let's go ahead and break. That means when you get to 5, it's going to stop the code at that point, and then you're done. Okay, so let's go ahead and execute that. Enter a number. Let's try 10. Count all the way to 6, and it's done. Again, the reason we ended at 6 is because we updated our counter before we broke it. If we had this before updating our counter, then we'll see 6, 5, 6, and then 5. Does that make sense to everyone? So that again is breaking right there at 5. Otherwise, if you don't want to break out of the loop to terminate it, you can use continue. Continue is just going to skip number 5 and ignore it and continue with its business. Okay, so let's execute that. Let's try 15. Starts from 15, going down. And when it gets to 5, well, what am I missing here? Oh, that's why. The reason I'm printing that is because I have the print right after that. So let me make changes here. Cut this and put that right before. So if I have continue, it's going to skip that. Otherwise, it's going to print it. But I want the counter to always update. So let's execute that. Try 15 again. No, it wouldn't print. Okay, there you go. Run that. What am I missing? Okay, so let's see. If counter is equal to that, continue, print counter, counter updates. No, I think I'm missing something here. No way. That's good, that's good.
So the condition we are giving is while counter is greater than 0, and we are also saying if counter is equal to 5, it should continue.
Yeah.
Then we are giving a number that is greater than 0 and is also more than 5.
Yes.
We will not continue until the number that we gave.
No, it should be good. It should be good. I think we should be able to run it just fine. But I want to, let me go ahead and see if this is going to answer my question. There you go. I feel like I'm missing an indentation somewhere. That's what the issue is. So there you go. All right, so let's try 10. So as you see, the counter gets updated. 9 all the way to 5 gets skipped.
Yeah.
Okay, but if I had break, then it's going to break.
It's gonna break it once it hits 5.
Out of it once it reaches 5. So 10, and then gets to 5, and everything stops. Does that make sense?
No,
Yeah.
sir, I think I'm missing something. Why are we assigning counter equal to 5 again? Is it the intention? Is it to skip or to do something when that counter reaches 5?
Exactly. So what we're doing here is, let's say we have a party that's supposed to be for, let's say, Petit Pay is coming to a concert, all right? He's coming to the concert, and then we said we're going to let people come in. As soon as Petit Pay gets into the building, we close the door. Nobody is getting in anymore. Okay. So at that point, when you're checking all the numbers that are going through, we're going to ask the user to enter a number. Let's say they enter 10, 20, 30, whatever number. We go ahead and make sure that that number is going to count down all the way to 0. So we update that number by reducing 1. And then we check if the number meets a particular condition. In this case, we just chose condition of 5. Okay, whenever we see 5, we're going to stop. Nobody else is getting into the building. Okay, does that make sense?
Yes, it does.
Awesome.
Yes.
So check if condition is true. So if this condition is true, we're going to break out of the loop. Otherwise, we can use continue. If this condition is true, we're going to skip that particular iteration, and then we're not going to print that counter. So it's just going to go from here back all the way up to the next iteration and carry on. Makes sense?
So I'm careful with your choice of words there, right? If the condition meets 5, it should maybe it should break. Should the next one should be else there? Continue if something.
So let's say if it's continue, then it will be skip. Skip this iteration. Again, the iteration is that inner loop, not the outer loop. It's the inner loop. But if we had break, then we're going to exit altogether. So stop the loop completely. Okay, exit the loop. So depending on what exactly we want, if we want to break, then we can go ahead and run that for 10. It breaks right there. Or if we want to continue, we can go ahead, run that. And when it gets to 5, 5 gets skipped.
Okay, let's spice this up, NASA. If if Petit Pay is in the building, which is the condition that we are saying counter equals 5, close the door, right? So that condition gets met. Now, because we want to give Petit Pay that honor to be on the stage, then people are still outside waiting. So there is a wait time, maybe 2 minutes for Petit Pay to get on stage. Then continue accepting tickets.
There you go. So now you can set that up again. Once you break out of the loop, you cannot get back into the loop. So at that point, you probably want to put a pause. Okay. There's a third option though, which I didn't want to talk about. I think we talked about it earlier yesterday. The third option is pass. Pass doesn't do anything. It just lets you, it's just like a placeholder. Like we don't know yet what we're going to do with the idea of having 5. So if you execute that and you put 10, it's just going to execute just fine because we don't know what happens when we have 5. Maybe we want to have something else happen. Then tomorrow we can come back and say, yeah, that manager said they've decided that, when Petit Pay is there, let's maybe have some fireworks. Then we can decide that, okay, we're going to print fireworks. And then now that we've made that decision, the business decision, you can go ahead and execute that. When you do 10, when you get to 5, you have fireworks, and then you continue.
There you go. Okay.
Does that make sense?
Yes. So in this case, we are not using break or anything or exit. Okay. Break is like a hard stop. After that,
break is
nothing
like a hard
happens.
stop.
Okay.
Yeah. So it's also useful to have some of these in your code if you want to debug a loop. If you're having issues with a loop, you can always, debug, like figure out where the bug is by printing out. Because in some cases you might have a mistake. Instead of greater than, you have less than. Instead of reducing the counter, you're increasing the counter, and so on and so forth. Sounds good? Excellent, excellent. Very good question so far. So let's see where we are at. Since we were just talking about continue and break, it's only right that we get to break time. And just as we've been talking about, the first day we did say beautiful is better than ugly. Next we said simple is better. No, sorry. Next we said explicit is better than implicit. Today we have to realize that simple is better than complex, right? Tomorrow, or should I say next iteration, we'll have something else. So it's 3 minutes to the top of the hour.
Complex is better than complicated.
Exactly. It's better for me to make things complex rather than complicated. But in the meantime, let's keep it simple, right? Keep it simple rather than complex so everyone can understand. So I'll give you guys 10 minutes. When we get back, we're going to just do practice. Okay, we're going to practice all of these things, while loops, look at some of the examples that we did earlier, how we can incorporate that in there. We've already looked at loops with ranges, so that's fine. Like I said, I just wanted to hammer it down in this 1 hour to make sure we understand the concept of loops with indefinite cases and loops with defined cases. So 10 minutes of time is yours. When you come back, we're going to carry on with this. That's the rest of today. Sounds good?
Is it a hard break or a soft one?
It's a 10 minutes break. Then very good one. It's not a hard break, it's a continue. We're gonna have it 10 minutes. And then we'll carry on from there.
That was a good one.
Yes.
Very good one. Very, very good one. So let's go.